for homework, but I'd like you can copy down what you've got prepared from your homework onto the Google sheet. But please answer this question. What did you predict and see happening with digestion and respiration in today's observations of the lab? So I know some of you, maybe in your predictions you said, I think my balloon will get bigger, I think my balloon will not get bigger. I don't want you to only be concerned with the balloon. We're talking about these processes that are making this happen. So I want you to think about, what do you think is happening? What do you think you're going to see today when you're looking at it? I'm going to have you guys do a couple things for today. You're going to start off by looking at your data, or you're going to be taking data for today from your class from yesterday. Got it? I'll outline it here for you. So the first thing is to take day 2 data. And when I say day 2 data, I'm not talking about every 5 minutes you're taking the data. I just mean take one last piece of data today. Just measure the balloon, measure the height, and just add that as day 2's data. And then after you're done with that, I'd like you, as a group, to write one conclusion statement as a group. If you'd like to each write an individual one and then kind of share out, and then write one, I'm going to come around with paper and you can write your group's final conclusion statement on that piece of paper. These are the 3 things I want you to be aware of too when you're writing your statement. And these are 3 things that we've kind of been practicing throughout the year already. So you want to start off by answering your investigative question. Be sure to include evidence by using relevant data from your experiment. What do I mean by that? When I say be sure to use evidence, what does that mean? Yes, Spencer?
Like something from your experiment, like the yeast started to bubble up because it went up 25 milliliters in the flask.
Great, so using some data, using relevant data, so you talked about the amount of bubbling up. What other kinds of evidence can we use? Nika?
Circumference of the balloon.
Circumference of the balloon. Great. Anything else? So the amount of bubbles, circumference of the balloon.
Probably like some data, but like something that like data and stuff.
Yeah, so what kinds of data? That's what we're asking. Anybody else have anything? Any other types of evidence we can use to talk about digestion or respiration? We've got those 2. Anything else you guys take data on? How many of you paid attention to the level of stuff inside of there too? Not only the foam, but the solution that you started off with. Great, so that would be great evidence as well. So I kind of have them listed here for you. Some of you might have taken the width or the height as well as the balloon, and that would be evidence for you to include. When I say relevant data, what am I talking about? I saw this on the last exam too. So let's say you're answering your question, yeah, Lucy?
The
average, maybe? Any other ideas? Yeah, Tori?
Not just random stuff that won't add to the conclusion, stuff that actually matters in the whole experiment.
Yeah, so should you just record every single piece of data in your conclusion statement? Jane?
Just do averages.
Just do the averages? Okay. But what if you only did one trial though? Kind of you guys did one trial, so instead of doing an average, what else can you do? Yeah,
The highs and lows.
what was that?
The highs and lows.
The highs and the lows, yeah. So you can do any highs and lows to maybe make comparisons about the effect of temperature or the effect of a complex carb versus a simple carb. Great, so there's your second part that you need to include. And while you're writing that, I'd like you to explain what you think your yeast are doing in the flask. So when I walked around and looked at those predictions, a lot of you said, well, it made the balloon blow up bigger, but I want you to concentrate on what the yeast are doing. Any questions for you guys? So I'm going to give you probably at least half the period to get in groups, write a conclusion statement, and as a group, you're writing them in your journals, and then as a group I'd like you to write one final one that you'd like to present to the class. If we don't have time to present today, we're definitely going to present tomorrow. So make sure that you are ready to go with your conclusion statement. Questions? Okay, let's get started then.
What are you making sense from all this data? that the yeast did not need to do extracellular digestion because the sugar solution, it just started inflating. Oh wait, this one, yeah, it just started inflating instantly and it got much bigger. And now it's starting to deflate, sort of, because I think the yeast, the fungi in it, has gotten all the nutrients it needed, so it's just kind of winding down.
So when it had a lot of sugar, what do you think the yeast was doing with it?
It was doing the respiration, cellular respiration, and reproducing with the energy.
Oh, great. So we've got a lot of reproduction. So then now if you put together with Drew's idea where maybe some of this food is running out, what do you think is happening to where the energy is going? Alex, what do you think?
What was the question?
The question was, if we're putting these two ideas together where we know that the yeast are using the energy for reproduction, but we're also running low on the amount of sugar, and Drew pointed out that the balloon has gotten smaller. What is happening with the yeast?
They might be dying because there might not be enough sugar solution left, and because the number of yeast increased so much and then the sugar solution ran out, so now they might have ran out of sugar solution, or maybe they just don't need any more nutrients, so they stopped.
Great, so there's two sides of the coin. Maybe they just stop reproducing one the other, and maybe there's an overpopulation of them that's happening. Great.
That this one's not reproducing like yesterday because it's not, the water's not warm anymore, and it was reacting a lot more yesterday because it was reproducing, but there's still...
What is it about the heat that's making it reproduce a lot more, I think? Did you guys test the temperature? What was your variable? What did you test yesterday?
Complex carbs and simple carbs.
Complex versus, okay, so what
This is number 3 for less sugar.
this one has
Less sugar.
No, that's the 10%.
Like 1 gram, I think.
one, oh, this has the smallest amount? Okay, and this has the medium amount?
No, this is separate. This is a whole separate experiment.
Those two are the same, and this is just half of 3.
Oh, okay, I see what you mean. So this is sugar, this one here is sugar?
Yeah.
Okay, and this one is starch. Great, so what did you find out?
Found out that in simple sugars, yeast reproduces more than complex sugars, because on the data table it shows that like at minute 20 it was like 300 plus for simple sugars milliliters, and it was for complex sugars like 125.
Great, and so what do you think is happening there? Why is that happening faster and more in this one with the simple sugar? What do you guys think? What's going on with this process of maybe digestion or respiration?
Probably just because it doesn't have to go through extracellular digestion, so it can just digest them faster in here than it can in there.
Okay, and so if it digests faster, what does it affect in respiration?
It just increases the speed of the whole process, so it's like skipping a step in the process. So it can.
Yeah, so
respirate
you're saying
faster.
that it'll work faster in digesting, so it's breaking down the complex carbs into simple carbs. What else is happening faster as a result of that?
The respiration.
Respiration. And what is that though?
That's the
And you were,
balloon. That's the balloon.
yeah, but what about the balloon? The balloon is getting bigger, but what does that mean about what the yeast are doing inside of there?
It means the yeast are reproducing them.
And you kind of talked about the balloon too.
Yeah, they're letting off gas.
Yeah,
That's
so-
when the gas rises to the top and it fills up the balloon.
Great. And so it sounds like what you're saying is there's a faster process of getting the simple sugars, and because of that, then they're able to do that second process a lot faster. Oh, you have 3 here. So what was your question here?
What happens if yeast do not have enough or have too many nutrients?
Great. Can you tell me what the setup was here?
That was the
1%? What is this one here? 30, and this one? 10. Okay, so it kind of goes like that? Yeah. Great. So what are you noticing? Do you notice any pattern?
This one's the biggest.
And then the second biggest one.
This one's the smallest.
And this one looks dead. Wait, is that kind of what you predicted would happen too?
Kind of.
Yeah.
Kind of. Yeah. So what do you think's going on then? Why is it
The
that we've
more yeast, the more like sugar and the yeast inside of the flask, the more the balloon will rise.
Yeah, because why? What are we talking about that's happening? What are the yeast doing?
They are reproducing. No. I don't know.
What do you guys think?
I think that I can agree with Nana that they're reproducing, so that's causing the gases to rise into the balloon, and there's more nutrients in there, and it breaks up all of the sugars. Enzymes will break up the sugars.
Are enzymes breaking down sugars? Take a look at that process breakdown. So did you guys use sugar or starches here?
And things break down starches.
Oh, you use starches in here? Or sugar?
Can we use starches?
Yeah, we use starches.
Okay, you use starches. Oh, okay. Great. So, so we do have some kind of digestion happening here when things are breaking down. Great. Where is this gas? Where's the gas coming from? You said that it's making the gas rise. But where's that gas coming from?
Well, it takes oxygen to like blow up a balloon. And like if a person blows up the balloon, it's their oxygen coming out. That's how the balloon's getting bigger. But
Are
then
you blowing out oxygen?
wait no
Wait,
carbon dioxide.
yeah. But there's oxygen in there to help the
Energy and gas at the same time.
Oh, so the energy. Oh, you're talking about. So I think you're talking about two different things. You're talking about the balloon that you're blowing up carbon dioxide, and you're requiring oxygen for that energy that you're saying.
Yeah.
Okay. So then, if you've got oxygen and you've got energy in there, then you can kind of see a pattern here with these three here. Which one of these do you think had? Let's see. Oh, so this one had the most. Okay, I think I'm understanding. Okay. So did you take a final data measurement?
We're doing that.
Great. Yeah. Let's start doing that. I'm gonna come around and also stamp you guys.
The water's cold now.
It was too
It's
cold when we
17
started it.
degrees Celsius now. It used to be 30 degrees Celsius. Okay. There, and when we were taking the measurements, it seemed to stay at 30 the first two times we recorded it, and then it was at 35, and then it went down.
What went down?
The temperature went down from 35 to 33, then to 30, and now it's at 17 today.
Great. So you're taking. It looks like you took data on temperature, but did you take any data on the effect of the temperature on anything else?
We got how much like the bubbly stuff was, and the width of it, and how much the water.
So what did you find out? Do you find anything that you can conclude based off of comparing these two?
Well, the one with the temperature, the water level rose. It used to be at 100, now it's at 115. And they're both, their width, when we measured it today, we're both at 15.5 centimeters.
They're the same.
Yeah, and that one used to be 12 centimeters, and this one used to be 15.5 centimeters, and it didn't really grow that much. The highest it went was 16 centimeters, and the lowest was 15 centimeters, so it didn't change.
Okay. But you definitely can compare the two, what's happening between the two. What can you see that's happening?
That 1 degree, like 1 degree in temperature can change what the fungus do.
And what are they doing?
Eating more and they're letting off more
Eating
CO2.
and letting off enzymes, laying off enzymes, and then letting out gases.
Did you guys use, what did you start off with in your solution here?
We did structures.
You used structures, so you're saying that it's releasing more enzymes and what else?
It's breaking down more enzymes, and what I kind of thought yesterday was that it wouldn't rise that much because since we have the same amount of starch solution, it won't have, and it eats a lot of it. It won't have that much to eat, so it's gonna start dying out.
Oh, good point. Yeah, because you've got a lot of that energy being used for reproduction, so it's going back. And you're talking about overpopulation.
Yeah, and not enough food and things.
And so, do you see kind of that happening here?
Well, it was like down like this, and then we moved it a bit, and it popped up. But they're the same width. They're the same in diameter. So
did what you think happen?
it probably hasn't happened really yet.
It doesn't really work that good because the water in the sink doesn't get warm enough.
Okay. So you think that if we kept that warm all day yesterday and all day today, what do you think you would have seen then?
It probably would have been kind of more flat since the heat would have made it release more enzymes. But since it grew cold so fast, we probably didn't release as much enzymes since it grew colder. And so it wasn't as excited, so it didn't rise that much.
Great. It sounds like these are some great observations and great explanations of what's going on. So let's start maybe formulating. Did you take your last data for today?
Yeah.
Great. And then you can start talking about what you want to include in that statement. I'm going to sample you guys for some of the work that we did yesterday.
Faster so that the level of the foam, I'll just call it that, would be a lot higher. And since today it is a lot colder, the foam is a lot less, because it's not as working as hard because it's colder and it doesn't have enough heat to work faster.
Okay. So when you say work faster, what does that mean? Like, what is it going to be doing?
Like eating more.
Eating more.
And like, it's digesting faster or slower, and it's also producing either more or less CO2.
Okay. Anything else?
Does it matter how hot the water is? What if you put boiling water in?
That's a good question.
Oh yeah, because if it's too hot, then the yeast will die. So if you have to do it by a certain margin, or else it won't work because the yeast will die. So I think we used hot enough water so that it will produce but not die.
So what is temperature affecting in activity 46 when we kind of scripted out what this process, all these different processes are doing? What is temperature affecting then in here?
Well, in this
Or you can even look at the pictures too.
Yeah, and I think heat helps it happen faster. So that would obviously prove that if it's hotter because of the heat that the water's giving off, that the yeast will work faster because of the heat.
When you say work, what do you mean by working?
Well, like eating its food.
Can you describe it to me in terms of what you see here? Or yours, yeah. Either one. Anybody can answer too, Nina or Lizzie. Because you're saying that heat's helping it work faster, but what does that mean by working? What are the yeast doing?
Relax, have my copy first.
Well, the complex enzymes. Well, it might be since heat helps it happen faster.
What happened faster? What process is happening?
Well, it sends down enzymes to go digest the food, or break it down into simple carbs, and then it adds oxygen to produce energy and gas.
Copy something here.
1 second, Wyatt, please.
And so, what it's probably doing, since it's heated, it's probably sending down more enzymes, so that it can get more simple carbs. It can eat it, add the oxygen, so it can produce more energy and more gas. So there's sort of like a whole circle. It just keeps going over and over.
Oh, great, yeah. So it sounds like you guys are really understanding what's going on.
Yeah.
I already stamped everyone for the work. And I
can't cross.
They stamp you guys for your work. Whoa.
Yeah, that's a 30-gram balloon.
Is that the, and what are these ones here?
Okay, we named them up 10 and 1, and Brenda's making a visual for the thing.
Oh, that's great. And you know what? Yep, I think that's a great idea because tomorrow we might even see something different happening too.
Yeah, so that's what we're doing right now.
That's a great idea. So do you think what you're seeing here, was your prediction correct then?
Not
What
at
do you
all.
think was going to happen?
I thought that it wasn't gonna gain anything.
Which one?
This balloon. I thought it was gonna stay that way because it might have had too much sugar like we do. But I guess I didn't realize that
it may have not like eaten all the sugar. I mean, turned all the sugar into energy, but in that process, it made a lot of gas in the balloon. So that's what I kind of learned.
Yeah, and so what do you think would happen if we set up maybe another flask with like a lot more sugar?
It would gain more. I think it's more. It's like when the more you put in, the more you get, the more balloon you get.
How come this hasn't gotten any bigger?
Maybe because it's produced all the gas it can. Maybe it ate all the sugar up. You know.
Oh, so there's maybe a limitation to food. So if it has unlimited sugar, do you think it would continue to get bigger and bigger?
Probably.
What do you think is happening with the yeast in there? You said it's producing gas. Is it doing anything else as well?
Maybe reproducing.
Okay. So if it's reproducing a lot too, do you think then that would affect what's going on?
Yeah, because if it reproduces too much, there wouldn't be enough food for everyone, for all the yeast cells, and then it wouldn't produce gas anymore.
So it's kind of a cycle that's affecting itself. Great.
Do you make any sense, or I started?
Okay.
So which questions do you guys investigate here?
Option 1. Does it
Option
need
1.
extracellular digestion to produce energy?
Great. And so what did you notice about these two? What's the difference between these two?
Well, in this one, it went a lot faster and it started reproducing like crazy, so much so that the yeast cells were like reaching up into the balloon, like almost to the top.
So you actually had stuff inside of the balloons?
Yeah.
Oh, really?
And like this one was very, very slow, but it's still a lot more alive, it looks like. And we think, like, we're not sure, but we think that they all died because they ran out of food and, like, all of them are gone.
Oh, okay. So that's a possibility that maybe there's a lack of food in there. I'm going to come back and take a look.
Whoa!
So, okay, what? So it looks like this group did you use starch or sugar? You used sugar. And you guys used flour. Oh, you used starch. Great. So can you guys kind of explain what you did and what you did so that way we can...
We added 1 gram of sugar to this one. We added 10 grams of sugar to this one, and 30 grams of sugar to this one.
We had 1 gram of flour, what was it, 10 grams of flour and 30.
Great, so let's even kind of put them here. So what do you notice about those?
The sugar's the one making it rise because the more sugar and yeast mixed together, the bigger it will rise.
Yeah, but why? What's going on with the yeast? Why is it that you're seeing you're seeing kind of the same pattern happening here, but why is it so much more dramatic in the sugar?
Probably because the sugar is turned into energy, and that's the process that they use to like make the gas and stuff. And that's cellular respiration, and they may be like reproducing, so it may be like really big dramatic change.
Yeah. So what's happening? Why is it taking so much? Why is this so much less than this here? What's going on with these balloons here? What do you guys think? Now that you're comparing it to the ones with sugar. Let's look back at 46 too. Maybe that'll help you out.
We have to break down the starch to get the sugar, so that's why it's not as fast. Yeah. So maybe it may gain tomorrow or something, but ours won't.
It might stay the same.
Yeah.
So what can you say about energy or cellular respiration? Is it still happening? Do you have to do digestion to produce energy?
I think so.
Yeah.
I'm saying just in general, do you have to have digestion happening, that first part of that process happening in order to come up with energy? Did you guys do did yours do extracellular digestion in yours?
I don't think so, because we already had the sugars broken down. But I think in this one they have to do extracellular because the starch is not breaking.
Yeah, so in general, looking at both of these here, do yeast have to break something down first in order to get energy?
No. I think it's just like when we eat something sugary, it may break down faster or slower.
Like,
Give you a
people, when they eat like lots of sugar or candy, they get really hyper. So that could be like the balloon's case, because the balloon, the 30% one had 30 grams of sugar, so it might have got lots of energy to like blow it up.
Yeah, compared to
Yeah.
Great.
Compared to flour, because flour didn't have much. It doesn't really have any sugar. I don't think.
It doesn't have sugar, but what's happening in this one? It's still getting energy. So what's happening in that one?
It's taking a slow process because it has to break down. The yeast cells are taking slower to reproduce. Like, the other lady, she was, I don't know what her name is, but she was telling us, like, the CO2 bubbles, like, I forget what, but, like, our 1% one, it probably didn't have too many yeast cells to start out with, so it has a slower process of reproduction rather than the 30% one.
Right, and so that's
More rapid reproduction.
So
And then 10% has a lot of bubbles.
right, and I think that's a great observation to make, and maybe even include into what you're going to say when you present your conclusion tomorrow. Right?
Do we get a stamp for the conclusion? No. Oh, okay.
So what are some differences that you guys see in your explanation versus what he had?
Well, I had that the warmer water, it reproduced at a faster rate, so it created more yeast cells. So it had more yeast cells to produce more than the cold. So it was like a 3-on-1 action.
Okay, great. And what about
More.
what about the other group? Do you have any differences in what either of these two people thought?
Well, yeah. Our cold water increased a little bit.
Well,
It went
after.
through, no, but on the first day it went to 100.
That's probably because the ice method.
What about anything about digestion? Because I hear a lot about respiration and energy being used. What about anything about digestion that you guys came up with?
Well, the hot water, the flask, on the first day was full of foam, and so we're thinking that since it was hot, the extracellular digestion went a lot faster.
You guys started off with starch or sugar?
Sugar.
Well, is there anything that is extracellular digestion happening then if you're starting off with just sugar? Anybody disagree or want to add their ideas about what's going on? Maybe she can kind of revise what she's got. What do you think? Yeah, go ahead, Jay.
It doesn't. I don't think it would because since the sugars are the simple ones, and since they come after the complex and the enzymes, there's nothing to really break down. So it does maybe start off with that.
Okay. So real quick, Nico, what was your experiment? Just describe what the two or three classes that you had set up for.
Oh, we had 2 and then we just put hot water and cold water and then the...
Great. And you had sugar solution in yours? Okay. And then Joey, same thing? Sugar solution and temperature? Joey?
Sugar solution.
And temperature. Wow, interesting. So we didn't have anyone doing starch solution and temperature. Okay. Let's see. Maybe you guys can start talking about who's going to be talking, like maybe who's going to be presenting their statement, and who's going to be helping answer questions, maybe, or even looking through your journal because people are going to be asking people questions. So,
Starches.
So, for us, since it was hotter, it turned out that there was like a lot of foam. And what that would have meant is that, you know how in Act 46 where we said heat helps it happen faster? Well, since we kept it in the hot water, it stayed hotter for longer, so that meant it kept eating away at its food faster. So in the end, it would produce more CO2 gas and more energy. Anyone else? What happened to the starch? That's what I want to know.
The starches, we did the starches. They were definitely affected by the rise in temperature. The balloon inflated a lot more than the one that was just in room temperature. And so that, I think, maybe what gets put in doesn't really affect what it is, but there might be a difference.
Well, we also did starches, and what happened to ours was the one that was hotter or warmer, it stayed around 15.5 centimeters in the width of, in the diameter of the balloon, and it rose a little bit in the water, the solution level, and the one that had, the one that was without all the warm, it rose steadily by about, in the width, it rose steadily about like 1 centimeter, and then the water level stayed about the same. too much in ours.
So in general, what can you say about temperature? Which factors is it affecting?
I think the reproduction rate mainly, because you can really see there was a lot more foam in our flask. The foam was just about. Can I see the flask over there? It's tiny. Okay, the foam was only like about down here when we did the experiment. Then when this is not to scale. And then when we put the hot water in, it was like all the way up, maybe to the top, or maybe even some in there.
So which of these processes, digestion or respiration?
I think.
Respiration, it lets out the gas, and that's kind of like when it reproduces.
So you know that's respiration. What about digestion? Is temperature affecting digestion?
Well, maybe since it's a hotter temperature, maybe it's digested faster than it normally would.
Yeah, proof for that.
Well,
From research on the computer, it said that it makes the fungi excited, so heat makes fungi excited, so releases more enzymes.
Okay.
So it might affect digestion somehow.
Do you guys have evidence for that at all in the data that you took?
I don't think they all died. I think that it's
Some
yeah, I think
Not they
Yeah.
all. It didn't. The balloon didn't blow up anymore because of some of it dying, and it couldn't.
Well, our warm and cold water.
Yeah, same with ours. It looked like it was gonna pop because it was bubbling up into the balloon, all this foam, and then there's no foam at day 2.
I think
It died because it didn't have the use of all the nutrients.
Yeah, the first day it was taking so much of the nutrients up, and by the second day it wasn't.
Yeah, like they could all end up being 9 inches, but they just would happen at different times because they would do better in a certain temperature, from going cold to room temperature or hot to room temperature, and room temperature would just take longer
Because in cold temperature, the yeast doesn't die, it just doesn't grow. So you'll be left with the same amount.
yes, I think it had the same rate of producing gas and energy, so that's why it pretty much stayed the same after day 2, because it was pretty much the same temperature.
Well, it warmed up a bit. Like the cold one, it had nothing the first day, but by the second day it was bigger than the hot one.
Yeah, same here.
Ours was like a half an inch bigger. The warm.
So why do you think that happened? Why is the next day the cold one was
Because cold, it wasn't dead exactly in cold. So when it started to go to warmer, it started to reproduce and digest and eat all the nutrients and then reproduce more and release gases. So it was building up, so it would make the balloon bigger. And hot could have shrunk because it either died going into the colder temperature or it ran out of nutrients at blowing the balloon up 9.5 inches or 9. Who got more than 9 inches for the hot?
12.5.
Then on the second day, what did it
centimeters.
We had like 20. Okay, on the second day, what did it end up as? 9 inches. So for the second day, did anybody end up below 9 inches? Everybody did?
21.
No, anybody above 9 inches?
Yeah, we got like 10 or 11 or something.
We got 27. We got like 7 inches. Okay. So yeah, I think we got more. Yeah, and who got cold above 6 inches? In the second day? We got 10 for
Wait, can I see that?
okay, then so it's kind of the hot, no matter how big it is, it usually goes down to around 9 inches. And for cold, it goes up from 5 to 10 inches rather than from 0.
One thing I think I forgot to ask you guys to do was to draw a quick diagram of what your class looked like at the end of day 1. So for instance, this is from last period. They just drew a quick diagram of the experiment they set up. They labeled what was inside of it in class, and they kind of drew like a relative size difference between the balloon, between the experiments set up here. So what I'd like you to do is to have maybe one person real quick. I'm just going to pass it to the first person, but we'll have just one person in your group just quickly draw a sketch of your class. Of your classes. Okay, one thing, I'm going to talk about a couple things before we get started with our presentations. I passed out a yellow handout for you, and it looks like a big dad. If you're taking a look at your yellow sheet here, when you're listening to the other groups present their experiment, what I'd like you to do is to do a quick sketch of the class that they had set up and the results after day 1. And you're just going to kind of draw the relative levels of stuff and the relative sizes of the balloon and label them. So for instance, this might be your simple carve on this side, and this will be your complex carve. And when the group is presenting, you can draw the size of the balloon or the level of stuff based off of what they're saying in their data. Does that make sense for you for this part? Now, as they're talking about their experiment, I do want you to kind of sum up what you're hearing about extracellular digestion with this experiment here. Since this question, for example, for question 1, it says, do yeast need to do extracellular digestion to produce energy? I want you to sum up what are you hearing about this process here and the effect of this experiment on this process. Same with your relationship about cellular respiration. What are you hearing about this experiment and its effect on cellular respiration? Does that make sense for you? Any questions about that? Yeah, back.
So in that part, is there any room for that?
Yeah, and I'm going to talk about that later, so hold off on that. So you've got these things these columns to fill out as each group is presenting. And so if the group up here is presenting and telling you their statement, and you still have questions about parts of the model, I do want you to ask them the questions here, so that way you can make sure you have these relationships written down. So yesterday, did I tell you from homework you need to come up with a couple questions? Yeah. So I'm going to just do a quick brainstorm of the types of questions you can ask each group when they're up here. Since we're involving these two processes here, you can ask questions about any of these things that might be happening in their experiment. What are some questions that you came up with last night? Let's hear some volunteers. Everyone should have at least 1 or 2 questions written down. Ransom.
Why does the temperature affect the amount of gas going to the balloon?
Great, that's a good question. Why does temperature affect the amount? I'm going to put carbon dioxide specifically, yeah, of carbon dioxide. What other questions do you have? Yeah, Nico.
How do you know that the fungus didn't do extracellular digestion?
Good question. How do you know the fungus is doing extracellular digestion? Great. Patrick.
What was the largest circumference of either balloon at any time?
Say that one more time.
What was the largest circumference of either balloon?
But I do want you to kind of focus your question on one of these things. You know, when the group is up here presenting, they can just say, oh, 25.5 versus 22.2. So can you maybe change that question to include any of those things? I'll come back to you. You can think about it. Ben.
Is it possible to skip a piece of this process?
Oh, is it possible? Good. Can we change that so it's not a yes or no question?
I don't know. Yeah.
Yeah? Think about that. Let's hear another question. Back.
I have a question about this. If the question is our experiment, do we write down the stuff?
You should, yeah. You should still write those things down for yourself. Yeah, Ben.
What part is not necessary in the extracellular digestion process?
What process necessary for the what process?
For for the extracellular digestion.
What part of the process?
Yeah. Yeah.
Great. So now that you have a great question that you can ask, the way that this is going to work is I'm going to have the two groups that you guys split up into. I know they're really large groups, but I'll have, if that's okay, we'll just have everyone kind of line up across the front here. And you can show us your diagram. And then you can tell us about your experiment and just summarize what you found out. So you can use your conclusion statement to help us to explain what's going on with the yeast.
Okay, so what we did in conclusion, we found that yeast reproduces more in simple carbs than it does in complex carbs. And we think that is because, we think that because in our experiment, the simple carbs grew foam up over 300 milliliters, and the complex carbs only grew it up to 125 milliliters. And so we think that in the flask, the yeast are just skipping extracellular digestion on the simple carbs, which speeds up the respiration and reproduction rates, because it grew twice as fast as the complex carbs.
Can you show us your diagram?
Oh, yeah. This is at 0 minutes, that's like 10 minutes, that's like 20 minutes.
Our conclusion was no, yeast does not need to do extracellular digestion to produce energy. For example, the simple carbs, high for circumference of the balloon, was 32 centimeters, and water level was above the top. The complex carbs high was 20 centimeters per circumference, and water level was only 125 milliliters. This is because the sugar solution skips extracellular digestion and absorbs the sugar right away, producing a lot of energy to reproduce, while making gas to blow up the balloon. The starch solution was taking longer to absorb the sugar because it has to break down the complex carbs down first by doing extracellular digestion and respiration. In conclusion, the yeast with simple sugars only has to absorb.
This is our diagram. This is at the end of day one. The simple sugars, the balloon blew up a lot more than the starch. It was still hanging over and pretty flat.
What part most affected your experiment?
The warm water mixed with the yeast, affected the balloon to get bigger.
I think it was the fact that that they just skipped extracellular digestion, which sped up the process, so that you just eliminated a whole step.
What happened with cellular respiration in your experiment? Like, did it reproduce or not?
Yeah, it was increased because, like I said, the speed was increased, the whole process of the reproduction, respiration process with the simple sugars, but with the complex carbs it wasn't.
How do you know the simple carbs are absorbed quicker than the complex carbs?
We know that because since the simple sugars balloon grew so much bigger, that means it was absorbing the sugars and releasing the gas from the cells. So
If you said that you have to break down the sugars, what do you think the enzymes do?
Well, I don't know. I don't know if they even released enzymes. Maybe they can. We don't know about that because we didn't have any way to test if they did release enzymes or not. But they might have a way that they can tell that they're simple and they don't need to release enzymes. But we don't really know the answer to that.
What about the amount of energy? You said that it seemed like for simple carbs you had more gas and more stuff, more reproduction happening. Why is that not happening with the complex carbs? Is that happening with the complex carbs at all? What's going on there with the complex carbs?
I think it is, but it just is doing it slower since the enzymes are released and has to break it down before it can produce to get energy.
I think Alex, you were going to start to say something too with that.
I was just going to say that. It's kind of like if you have oil, you don't have to refine the oil, you just use it straight for purpose. It's just eliminating the whole process.
But why if you're skipping it, you're ending up with more? What's happening with that digestion part? What has to go into digestion? You said it's taking a lot more time, but also...
It might also lose some of it because
Some of what?
the stuff that's breaking down, like the complex carb, might just lose some parts of it because it doesn't need them. Anyone else have an idea?
Can you talk about it in terms of maybe energy? What's happening with energy, with the digestion happening too? Is maybe some of that energy that they would use to reproduce going back into digestion? Possibly?
Oh, well, it maybe because it needs energy to do the digestion, so it probably is sending some of the energy it makes to just back to digesting to make more energy. So that's maybe why there's not as much energy and gas being produced.
Any other questions for us?
Sure.
Nico?
I'd like to ask Kay a question. Why does it need oxygen?
So start the yeast can get nutrients to rise.
It's because it's a living thing and all living things need oxygen, probably.
And there's process where is oxygen really important? In digestion? In respiration?
Well, in that one part where it says sugars plus oxygen, it needs the sugars and the oxygen to do that part of the process to get the energy. If it didn't have oxygen, it couldn't complete that process and therefore can't get energy.
Can you see that happening at all when you're comparing maybe today's your class from day 1 to day 2? We'll revisit that question as we go along. Great, let's go ahead and give them a hand.
I'll start off real quick. Well, we were comparing, and there were some weird things going on because in the first day, the hot water we tested, because we tested temperature, whether it would in different temperatures would affect the way yeast releases gas. And in the first day, the hottest temperature grew the most amount, blew the balloon up the biggest circumference, and cold had nothing, 0 circumference. And on the second day, it turned out that hot deflated a little bit and cold inflated. So there was a range of cold going from 0 to 5 to 10 in between that, and hot having a circumference from 8 to, 9 and below pretty much, all of them. They could have started, for the first day they could have had 15 inches in circumference. It still went down more and more. Yes.
So basically on day 2, the cold was bigger than the hot instead of the other way around.
Yes, I have a theory that hot, it was so, the yeast was ready, it was thriving in hot and just reproducing, releasing a bunch of gas, blowing up the balloon more and more. And cold couldn't really grow, but it was still alive in the cold temperature. So when hot was, its temperature was decreasing, and it was rough on the yeast, so it couldn't really handle the cold temperatures. So it started dying and deflating the balloon. And then the cold
was used to the cold, so when it went up to hot, when it went up to room temperature, it was growing and reproducing and doing better in room temperature.
And we thought the warm water, like the first day they used up all the nutrients and sugars, so then they stopped reproducing and stuff.
Because there wasn't anything left. It filled up so high.
So I think temperature definitely affects it because the balloon equaled itself out and they both got to around the same temperature.
It's harder for yeast to handle the cold temperatures, but it can still live in the cold temperatures. It just can't grow and reproduce. But in hot, it helps the process by sort of like having a sunny day for us where it's easier to run around than when it's freezing cold and it stings our lungs.
And then when we did the researching about the yeast, we found out that if it was too cold, the enzymes would stop, the yeast would stop releasing enzymes. Like it slowed down until basically it would just stop.
And you can also tell that the reproduction is being completed in the warmer glass because the solution rose from 100 milliliters to 150 milliliters.
Are there any questions for that now?
No.
Corey.
What do you think would happen if the water was cold?
Well, the yeast probably wouldn't survive in boiling water since, like, we couldn't survive in boiling water. I don't think very many things could survive in boiling water, but because it would probably just fry them alive, just like keeps up food for us.
With what Lucy said about if the water is too cold, the yeast can't release enzymes, it's the same with water too hot is what we found, like any extreme temperatures.
Yeah, basically at like 1 point boiling water, basically, they died. They like
Okay, so do you think that the yeast is produced better in boiling water or almost frozen water?
I
would say frozen.
Yeah, because it still might live in frozen water. It just wouldn't be active. But if it had time to, if it went from boiling water to room temperature, then we would definitely go with freezing cold water to room temperature. Patrick.
What temperature do you think the yeast would thrive at?
Probably, we did
Around probably.
if it kept at a constant rate of 50 degrees Celsius. So that's like, well, that's like 120 degrees Fahrenheit or something. Well, if it kept at a constant temperature, it would thrive at a warmer temperature, like 50 degrees Celsius. But if it just started at 50, ours started at 50 degrees Celsius, and then it went down to room temperature, and there was no effect at room temperature. So it has to keep at a constant spot to be grown. Any other questions?
Let's focus our questions back on the processes too, because we're talking a lot about temperatures and living and dying too, but maybe we can kind of focus back on those questions that we have up on the board even. Oh, we go ahead and ask somebody a question. Either from the board or from what you got.
Okay, hey Yanni, got a question for you. How can you tell that the yeast in there is producing a lot of energy?
Well, you'll see a lot of foam on the glass if it's hot. If it's cold, it's not working.
How so?
Maybe we can help them out too.
Well, the balloon's obviously going to fill up if it's working, but if it's not working, the balloon's just going to, it might even, since somebody yesterday said that cold could be the opposite of hot, and when hot actually grows, we were thinking that the balloon would start coming in on it, but we could never really figure it out. But if we kept it in a refrigerator, it could do that, trying to get air, more air that would be better to breathe and reproduce, or warmer air. It might start sucking in the bloom.
So let's go kind of focus back on where is that energy going towards. That's all this question is really asking. How do we know that the yeast are coming up with all this energy?
Milliliters may
The
increase.
solution,
I would like anybody.
well, the solution rises, and then you can tell by that because basically they're reproducing a lot, and then that takes a lot of energy, so you can measure. Could you show us some of the pictures?
Well, mine's sort of ugly, but this is our hot flask, and it grew 9.5 inches on day 1, and it stayed that all the way through day 2. Then we have our room temperature. We did 3 flasks. It was 6.5 inches, and then cold. The first day it was 0, and then it grew up to 9 inches, and I bet it would have kept growing if it had more nutrients. And
So ours we just did 2 cold and warm, and then the warm one on day 1 grew up to 12.5, but then decreased 4.5 inches to 8, and the cold ended at 7 on day 1 and just stayed.
Okay, so our picture, this is warm, the big one. It went to 12.5 inches, and then around it, and then the warm, it rose to like 250 milliliters, and then the cold was only like 4.5 inches, and then it rose only 115 milliliters.
James, you have a question?
Okay, yeah, I have a question for Ian. So, which part of the process was being eliminated? Was it the enzymes just wouldn't be expelled by the fungus, or was the fungus just like hibernating, or was it alive but just not being enzymes?
The fungus was alive.
well,
Let's have, since you share on what you do too, I want to be sure that everyone else gets a chance to kind of contribute too, because that is a great question. So how do we know, is it the temperature that's affecting the enzymes, or is it the temperature that's affecting the energy used?
Well, it was. It just wasn't reproducing with the yeast. The yeast wasn't reproducing. But then once the water started to warm up a little, then it started to reproduce and produce gas and energy.
So it was still digesting, just not reproducing?
Yeah.
Yeah, so like in warm water, what it does is we think that it was getting stressed because it thinks that it's probably going to fry up, so that's why it's reproducing faster. But in cold water, it'll eventually just even out because it knows that it's probably not going to die, so it can take its time in extracellular digestion or respiration.
Patrick?
Why do you think the one in the heat respirated more on the first day and deflated on the second day, and then the cold did the opposite?
Well, just like human bodies, when we run around, we're more energized and you're using a lot more energy. And so I think with the warmer temperature, they're just using up more energy and using it to reproduce. And with the colder, our bodies again, you're like that most of the time, and you never feel like running, you hardly feel like doing anything. And I bet that's how the fungi feel in the cold.
Yeah, and human bodies, they warm up eventually if it's cold, so that could explain why there's all this gas on the second day, because the cold water reflects the room temperature.
So if you're not moving around a lot when it's cold, then what's happening with energy?
it's just been stored up.
Yeah.
You're just stirring it up and not releasing it.
You even breathe slower, when it's cold.
Any other questions for Okay, so just to sum it up real quick, so temperature is affecting, somebody just describe, is temperature affecting digestion or respiration or both? Just to
I
sum
think
it up.
it's affecting respiration because it's not really doing the digestion phase.
Why?
Because it's starting off with simple sugars, and the digestion phase is breaking down the complex carbs into the simple sugars. So I think it's affecting respiration on like how much energy is being produced. Because like how you said, if it's cold, it'll just store it up and release it like not as fast as if it was warm.
And it would have been interesting because I think everyone who's standing up front did simple sugars and tested the effect of temperature. What do you think might happen if we did starches?
I think that the warm would, like, it would take a little longer, but it would still be produced faster than the cold. So that I think the cold would be like really slow.
So you're thinking that maybe digestion will just happen slower? So are you thinking that maybe temperature is affecting digestion too?
Probably.
I think the overall room temperature would have to be a little higher because it has to do digestion too.
Okay, let's go ahead and give him a hand. Great, let's give him a hand. Thank you.
Our question was, what happens if yeast does not have enough or have too many nutrients?
We tested each of the balloons. One balloon had 10 grams of sugar in it, one balloon had 1 gram of sugar in it, and one balloon had 30 grams of sugar in it. And we're all going to now explain about the measurements for day 1 and day 2.
The 10-gram balloon had 7 inches the first day and 10 inches the second day.
The 1 gram balloon had 7 inches the first day and 7 inches the second day.
The 30-gram balloon had 6 inches the first day and 14.5 inches the second day.
We observed that on the first day all the balloons had chunky stuff in it. After a little while later, the flask was all bubbly and it had a thin layer of foam. The 1 gram of sugar balloon blew up the most on the first day. The 10-gram balloon blew up the most on the second. The 30-gram balloon blew up the most on the second day. The next day we pretty much observed the opposite. The 30-gram balloon was now the biggest and the first balloon stopped growing and it was now stopped.
So, in conclusion, the flask with 30 grams of sugar had the biggest balloon because the 30 grams of simpler sugar gave yeast more energy. So it reproduced and produced more CO2 gas, and that's why it blew up so much to 14.5 inches, in which the balloon filled up with. And the balloon will not grow any bigger, we think, because of the yeast cells, and they may not, because they must have reproduced a lot with all the energy, and because they used all the energy for reproducing, there were probably not enough food to supply all the yeast cells with all, and that's why it stopped growing. So, any questions?
How do you know digestion is happening?
Well, theirs was digesting because they had starches breaking down the first day, and then the second day they blew up. So that meant that they did the first process and the second process. While we kind of skipped the first process since our stuff had already broken down into simpler sugars, and all it had to do was absorb and do cellular respiration to put it into a cell membrane and produce energy and reproduce.
How do you know that the yeast are getting energy?
Because there's more foam on the top and it had bubbles and stuff like that. And there's more gas because that was part of cellular respiration. And in cellular respiration, you take all those simpler sugars into energy.
How do you know that enzymes are released?
Well, in our process, like I said, we skipped the first phase of the process because ours was already broken down into simpler sugar. So we just had to do the second phase and the third phase of the process, which was cellular respiration and absorption.
Okay.
So is there a point where it's just too much food that it can't handle eating it all?
Yeah.
Well, Netta can answer that question.
Okay, so if a person eats a lot, they get really big, like excessive amounts of junk food. that's kind of the same thing as the balloon. If the balloon has yeast cells, and if they like eat a lot, they're gonna get bigger and keep reproducing, which makes the balloon get bigger. And then soon, when it's like passed up to the roof of the balloon, it's gonna pop. So yeah.
Beyond that.
How do you know that they're releasing CO2?
Because because in the start phase of the process, it's releasing CO2 because the balloon is filling up with gas, and that's how it's getting bigger. Because if there was no CO2 or anything in there, it wouldn't blow up. So, any other questions?
How do you know respiration is happening?
Well, because why doesn't Brenda answer that question?
Yes,
I don't know. Well, it probably is like the respiration is happening because it's producing gas, which is filling up the balloon, and that's part of the respiration process when they reproduce.
Oh. How do you know that they're using oxygen? How do you know they're using it and not just like not taking it in?
Well, we know they're using it because they reproduced, and it had like the balloon blew up, as I said. Yes, it blew up, Jamie. The balloon blew up with like the oxygen and the gases, so that meant it was using it for something by reproducing. Yes, Micah.
Can I see the pictures one more time?
Sure. Oh.
Miss Bauer?
So while we're on the topic of oxygen, and you guys tested out the amount of nutrients and how that affects whether yeast will get enough energy to do these things, is it possible that maybe the yeast can run out of oxygen at all? What do you think? If we added, let's say we added a ton of sugar, way more than the yeast probably need, what do you think would happen?
Well, the yeast probably reproduce. Well, like, it may run out of oxygen because they need a balance. Like humans, if we don't have enough like water or food, we die. So if it didn't have enough oxygen to complete the process of breaking down food and respiration and extracellular digestion, extracellular respiration, then it may die. So it may need a certain amount of oxygen.
So would you see that balloon ever getting so big that it pops then?
Yeah, because if it's already that big, like if we put...
Let's say you use the same amount of yeast, same amount of water, you just add a ton more sugar.
But I think it was because it's already really big, and obviously at one point it is going to pop.
Well, we'll tie that idea down with what Janie just said about oxygen and food too. Will it just continue to keep getting bigger and bigger?
It may, like on our balloon, we added a lot of sugar, so it may run out. Like ours, it ran out of sugar, so maybe it doesn't. Maybe it won't pop because it eventually runs out of food, like we do and stuff. So it eventually runs out of food and stops. So.
Do you wanna? I'm gonna ask this question to Justin.
Yay for Justin.
How do you know that how much it blows up is not affected by how much oxygen you get inside the container?
What was the question again, Dion? Sorry, Brenda didn't hear.
How do you know how it's affected and how much the CO2 releases and things like that? Because you probably got a different amount of oxygen, and so how do you know if that affected it or not?
Well, maybe like the oxygen, maybe like if you tested like the oxygen levels and such, if the balloon is blowing up because of gases, so then that means there's oxygen inside the balloon because it wouldn't blow up if there wasn't any gas or CO2 or oxygen before. So. Okay, more questions. Great job, Jamie. I know you took a lot of that responsibility there. Great job. Let's give the entire group a hand. Yay!